Students, this topic will help you to calculate the formal charge on an atom in a molecule or an ion. If you see the exams of IIT JEE mains exam, if you have this type of questions how to calculate the formal charge on each atom of some oxygen or some ions, like the questions you may have in your exams. So for that this video will helpful to you. So let us start our class. Now the topic is formal charge on an atom in a molecule. First let us see the definition of the formal charge is the charge assigned to the atom in a molecule assuming that electrons in all chemical bonds are shared equally between the atoms. Let us see clearly. In a molecule, there is no charge on the molecule as a whole or in a polyatomic ion, that is carbonate ion, just like carbonate ion, that means CO3 2 minus, or ammonium ion, NH4 plus ions, etc. Although the charge present on the ions in the charge on the ion as a whole and not the individual atoms, yet for some purposes it is useful to assign the formal charge to each atom or a molecule. Let us see one by one with the help of examples. If you see the atomic structure, molecular structure for NH3, then nitrogen, it has NH3 structure, and upon the nitrogen atom there is lone pair of electrons, LP, lone pair of electrons. That means these two electrons will not participate in the bond. So these are just individually just placed on the nitrogen atom. These electrons are called as lone pair of electrons. And here also another two electrons are there. These are participated in the bond, so that these two electrons are called as bond pair of electrons. Why I am explaining these everything? That means if you want to calculate the formal charge on an atom, you have to know the bond pair of electrons and the lone pair of electrons around the central atom. And the next example, before going to do the examples, you have to know the formula. For the calculating the formal charge, you have a formula, that is I am going to tell you. The formula is the formal charge Fc on an atom in a molecule is equal to, that means we have to calculate the formal charge. For this, the formula is the total number of valency electrons in the free atom minus the total number of electrons of lone pair, that means non-bonding electrons. Lone pair of electrons, that means non-bonding electrons, minus half into the total number of shared electrons, nothing but bonding electrons. This is the formula to calculate the formal charge. That is, let us see, this formula will be, we can write as Fc is equal to total number of valency electrons minus total number of lone pair of electrons and minus half into the total number of shared pair of electrons, that means capital S, that means shared electrons, nothing but bonding electrons. If you applying this formula for the calculation of the formal charge on an atom, let us see with the example. The sum is example 1. Calculate the formal charge on each atom of ozone molecule. Calculate the formal charge on each oxygen atom of O3 molecule. For this, let us see the structure of ozone molecule. Ozone molecule, it has 3 oxygen atoms, just like this. If you denote the Lewis dot structure, the pair of electrons, the valency electrons, just like this. Here 2 lone pair of electrons, here 3 lone pair of electrons. Then the atoms have been numbered 1 and 2. 3. And if you see the structure of the ozone molecule, you can see in between these two oxygen atoms there is one double bond is located, and around this oxygen atom two lone pair of electrons are located. If you see these two oxygen atoms, there must be only one single bond is located. So for these, the formal charge on end of the oxygen atom numbered as 1. So if you calculate the formal charge, you can apply this formula to this structure. That means, first one, let us see the valency electrons of the first O atom. The valency electrons are, see, 1, 2, 3, 4. Actually, our valence electrons of the oxygen, let us see, oxygen, atomic number 8, 1s2, 2s2, 2p4. This is the electronic configuration for the oxygen atom. If you see the valency electrons in the last shell, that means second shell, there are 6 electrons. So oxygen atom has 6 valency electrons. Let us see. In this place of valence electrons, you can write here 6 minus. And in the place of L, L indicates what, students? L means lone pair of electrons. The total number of lone pair of electrons, that means non-bonding electrons. Those are, see, 1, 2, 3, 4. These two pairs of electrons not involving in the bond. So totally 4 electrons are not participating in the bond. And minus the as well as the formula, minus half into, see, S. S means what, students? The total number of shared pair of electrons. See, S means the total number of shared pair of electrons, nothing but bonding electrons. See in this structure, how many total pairs of electrons, bonding electrons? 1, 2 and 3 and 4. So here 4. If you simplify this one, 6 minus 4 minus, then 2 times, here 2. 6 minus 4 minus 2, how much, students? The total is 0. So the formal charge of the first oxygen atom is 0. Now if you see the second atom is nothing but the central atom. The formal charge on the central atom, central oxygen atom, numbered as 2. Then if you apply this formula for calculating the formal charge, again V means the total valency electrons, just as well as 6 minus the lone pair of electrons. See, students, the lone pair of electrons, how many are present in the central atom? Those are 2 electrons. 2 electrons and minus half into C in the place of S. That means shared pair of electrons. How many, students? There are totally 6. Finally, we got the answer, plus 1. Did you understand, students? See, if you see 6 minus 2, that is 4, and half into 6. Half into 6 means that is 3. Then finally, the formal charge on the central atom of the oxygen, in the middle atom, has plus 1. That is the formal charge. Then if you see the third atom, we can give the number as 3. For this atom, if you see the formal charge, the total number of valency electrons for the oxygen atom, that is 6, and minus L. L means the lone pair of electrons. See, around this 1, 2, 3, 4, 5, 6 lone pair of electrons, that means the electrons which are not participating in the bond, those electrons also here 6, and minus half into, here see the shared pair electrons. Here see 1 electron, this 1 electron, bonding, sharing with the another atom, those are 2. If you cancel this, 6 minus 6, 0, and minus half into 2, that means minus 1. So minus 1 is the formal charge for the third oxygen atom. This is the examples for the ozone molecule. This is the structure, and for first atom and second atom and third atom, we can calculate that. Hence we represent O3 along with formal charges. If we get here plus charge and here minus charge. Why? Because the second central atom we got plus 1 as the charge, and the third atom has minus 1 as charge. So we can represent like this. This is the structure for ozone molecule. Let us see the second example. How to calculate the formal charge on sulfur present in HSO4 ion. Let us see the structure. Here sulfur, that means the central atom is the sulfur. Around the central atom HSO4, that means 4 oxygens must be there and another 1 hydrogen must be there. This is the structure, and let us represent the valency electrons like this. Hydrogen valence electrons 1, and let us see the sulfur. Before going to do that, you can write the sulfur electronic configuration. Sulfur means the atomic number 16. The configuration should be 1s2, 2s2, 2p6, 3s2 and 3p4. So the valency electrons are 6 electrons. First we can represent those 6 electrons around the central atom. 5, 6. And coming to the oxygen atomic number 8, then the electronic configuration should be 1s2, 2s2, 2p4. Then for these also 6 electrons are there. We can represent like this: 1, 2, 3, 4, 6, 3, 4, 5, 6. Now let us apply the formula for the calculation of the formal charge. See, the starting with valency electron, the sulfur valency electrons. If you see the electronic configuration, those are sulfur valence electrons must be 6 minus L. L, what it indicates, students? L means lone pair of electron. See, if you see this central atom, around the sulfur there is no lone pair of electrons, so the number should be 0. Minus, as well as the formula, half into S. S is nothing but shared pair electrons, that means bonding electrons around the central atom. 1, 2 and 3, 4. 4 pair of electrons, just like 8. Then if you simplify this one, 6 minus 4, you should get plus 2. Then sulfur has plus 2 charge in HSO4 minus ion. Let us see the second one. HClO4, this is the structure, and charge on chlorine in HClO4 ion. Then if you write the structure, that will be like this. Central atom is chlorine. Then you can write the electronic configuration for chlorine. Chlorine atomic number 17, the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So there are 7 valency electrons. 7 valency electrons in chlorine. And coming to oxygen, atomic number 8, 1s2, 2s2, 2p4 is the electronic configuration. If you see the structure, then you can apply the formula for this structure. Here see, Fc is equal to V minus L plus half into S. This is the formula. V is the total valency electrons for the chlorine, that is 7, minus lone pair of electrons. If you see the chlorine, the central atom, there is no lone pair of electrons. 1, 2, 3, 4. These 4 are the bond pairs. So 0 minus half into S. S means shared pair of electrons. See, only we counted 8 electrons are sharing electrons. Then if you cancel this, here 4, 7 minus 0 minus 4, that is plus 3. That means in HClO4, the Cl formal charge is plus 3, basing upon this formula. Formal charge formula, valency electrons minus lone pair of electrons plus half into Shared, let us recall the full concept, students. In this class, the formal charge on an atom in a molecule we discussed up to now. The definition C, basing upon the lone pair of electrons and the bond pair of electrons, we can represent and we can calculate the formal charge, and basing upon this formula and valency electrons, that means the total central atom has how many valency electrons, and minus lone pair of electrons, that means some electrons are not involving in the bond, right? Those are called no lone pair of electrons, minus half into shared pair of electrons. Shared pair of electrons nothing but bonding electrons, the electrons which are participating in the bond. By using these we can calculate the formal charge. In these examples also we discussed, that is first the ozone molecule 1, 2, 3, we should give the numbering to them, and for these 3 atoms in this molecule we can calculated the formal charges. Finally we can represented +2 and minus as charges, and we saw the second example also, that is sulfur. Formal charge on the sulfur in HSO4 minus ion. This is also basing upon that formula. And the third example also HClO4 in this ion chlorine formal charge basing upon that formula. Then if you have any doubts, students, you can convey that doubt through the comment section. If you like this video, please share and subscribe this channel.